Hello everybody, Dr. Lloyd here. It's chapter 5, the integumentary system. Okay, so the integument is the skin, and the integumentary system consists of hair, skin, and nails, but also sweat glands and sebaceous or oil glands. The skin consists of two distinct regions. You've got the epidermis, which is the superficial region. This is consisting mostly of epithelial tissue, which is avascular, so there are very few blood vessels. Under the epidermis, there's the dermis, mostly fibrous connective tissue, and this is vascular. And then the hypodermis, which is actually superficial fascia, which is the subcutaneous layer deep to the skin. It's not part of the skin, but shares some of the functions. It's mostly fat for shock absorption and insulation. Also works to anchor the skin to the underlying structures, mostly muscles. Okay, so here's a good picture of the skin. So we've got our hair shaft, pores, the epidermis. This is top layer. It actually comes in 7 different layers, depending on whether you're thick or thick or thin skin. And then under that's the dermis. The dermis is made of the papillary layer and the reticular layer. And then you've got your hypodermis, which is the subcutaneous tissue. Not part of the skin, once again. It's just below the skin. Okay, you can see some eccrine glands. These are like your everywhere glands. We've got smooth muscle, erectile pillae. These are to force the hair follicle to stand erect. We've got sebaceous glands attached to the follicle, and then the hair follicle and the root. Let's see, we've also got some nervous structures, free nerve endings, lamellar corpuscles, and the plexus at the root of the hair. So the epidermis consists mostly of keratinized, stratified squamous epithelium. These are the multiple layers of the squished epithelium. And there are 4 different cell types found in the epidermis. There's the keratinocyte, which produces keratin. It's the major cell of the epidermis. It contains desmosomes, which allow for a little bit of play when the skin is being stretched or used, and millions of keratinocytes will slough off every day. They will be dead. This is your dead skin layer. Then we have melanocytes. These are spider-shaped cells located in the deepest part of the epidermis, and they produce melanin, which is what creates skin color. You have melanosomes that are transferred to keratinocytes where they protect from UV. Besides keratinocytes and melanocytes, we've got dendritic cells, which are the cells of Langerhans. These are star-shaped macrophages that patrol the deep epidermis. These are part of the immune system. Then we've got tactile cells, also called Merkel cells, which are sensory receptors that sense touch. So the epidermis is made of 4 or 5 distinct layers. In thick skin, there are 5 layers. This is skin in areas of high abrasion, like the palms of the hand, the soles of the feet. Thin skin just contains 4. So let's look at thick skin first. You've got stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. This is thick skin. And thin skin is going to have stratum basale, stratum spinosum, stratum granulosum, and stratum corneum. It doesn't have the stratum lucidum. This is only present in thick skin. So let's go through these layers. The stratum basale is the deepest layer of the epidermis. It's firmly attached to the dermis. It's got a single row of stem cells that are actively dividing to produce new skin cells that then journey up to the surface. Okay, it takes about 25 to 45 days to go from the basal layer up to the surface of the epidermis, and the cell dies as it moves upwards. The layer is also known as a stratum germinativum because of active mitosis, so it's germinating these skin cells. And 10 to 25% of the layer is composed of melanocytes that once again produce melanin and skin color. The stratum spinosum is the prickly layer, but is several layers thick, contains a web-like system of intermediate prekeratin filaments which are attached to the desmosomes, and this is what allows them to resist tension and pulling. So the keratinocytes appear spiky, so they're called prickle cells. Okay, next the stratum granulosum, this granular layer, 4 to 6 cells thick. The cells are flattened, and in the stratum granulosum, this is where keratinization begins. So the cells start to accumulate keratin, and these cells will die as they approach the surface. The stratum lucidum, this is the clear layer found only in thick skin, like palms and the soles of the feet. There's a thin translucent band of 2 to 3 rows of clear, flat, dead keratinocytes, and it's superficial to the stratum granulosum. Then the fifth layer, the stratum corneum, 20 to 30 rows of flat, anucleated, keratinized dead cells. So they've lost their nuclei, they're heavily keratinized. And this corneum is most of the thickness of the epidermis. And the stratum corneum prevents water loss, protects from abrasions and penetrations, acts as a biological, chemical, and physical barrier. These cells, when they start out as stem cells at the basal layer, will eventually undergo apoptosis, which is programmed cell death, as they reach the surface, and then they are sloughed off. And humans can shed 50,000 cells every minute. Some people say this is the component of much of the dust in your house, is keratinized skin cells that have been sloughed off. Okay, so we take another look at the epidermis. We've got our stratum corneum, makes up most of the layer, the stratum granulosum, stratum spinosum, and stratum basale. So once again, the stratum basale is where you have the stem cells which start to differentiate into different cells, whether that's a melanocyte or a nerve cell or an epithelial cell. Okay, let's go down to the dermis. The dermis is a strong, flexible, connective tissue layer. It includes fibroblasts, macrophages, and occasional mast cells and white cells. Also contains nerves, blood vessels, and lymphatic vessels. Contains hair follicles, oil glands, sweat glands, and there are two layers. There's the papillary and the reticular layers. So here's the epidermis with your 4 or 5 layers. Here's your dermis. We've got, this is your basal layer of your epidermis. Your dermis, we've got our papillary dense region, which is areolar connective tissue. So there's a lot of air in here. And then below that, the reticular dermis, which is dense irregular connective tissue, right in here. So the dermal papillae are a superficial region of the dermis that sends finger-like projections up through or up into the epidermis. And these projections contain capillary loops, free nerve endings, tactile corpuscles, Meissner's corpuscles. We'll get into those in a little bit. Those are touch receptors. There are also ridges that are that begin in the papillary layer. These are friction ridges, and they're on the tips of our fingers. They enhance gripping ability, contribute to the sense of touch, and there are numerous sweat pores within the ridges. Let's see if I got a picture. Here's a picture. So here we've got these dermal ridges. And you can see the sweat pores, the little circles or little holes. There are numerous sweat pores. Some people have real sweaty palms. This is why. So the reticular layer makes up 80% of the dermal thickness, and it's got dense fibrous connective tissue, much elastin, which allows for recoil, and much collagen, which provides strength and resiliency. The reticular layer binds water and it keeps skin hydrated. There are other markings, especially on the hand and the foot. We're looking at here some lines. These are flexure lines where the dermis is closely attached to the underlying structures. These lines differ in different types of people. Most people have these two lines that one goes up, one goes down. If you've ever known somebody with Down syndrome, you'll see there's one line, it's called the simian line, that goes across. So not everybody has the same flexure lines. It depends on your genetic condition. Okay, so there are 3 pigments to skin color. Let's talk about melanin first. This is the only pigment made in skin. It's made by the melanocytes, which is convenient. Melanin made by melanocytes. The melanin provides UV protection. Freckles, pigmented moles, these are all local accumulations of melanin. Then we've got keratin, which provides a yellow to orange pigment, as well as hemoglobin, which is a pinkish hue of fair skin. Okay, hair. Hair is dead keratinized cells. There's no hair on the palm, soles, lips, nipples, portions of the external genitalia. But the hair has multiple functions. It warns of insects in the skin. The hair protects against physical trauma. It protects against heat loss, as well as has a little bit of UV absorption ability. The hair is also called pillae. So it's produced by the hair follicles, and it's just dead. Well, it's just protein. Okay, keratin. Now the hair does not flake off like your keratinocytes in the epidermis. So there are three parts to the hair shaft. There's the medulla, which is the central core. There's the cortex, which are the flattened cells surrounding the medulla, and the cuticle, which is the outer layer that has a single layer of cells. Here's a picture. So we've got the follicle wall with the hair in the middle, where we've got the cuticle, the cortex, and the medulla. So the hair extends from the epidermis surface to the dermis. There's a hair bulb, which is expanded at the deep end of the follicle. There's the receptor, or root hair plexus, which is a sensory nerve ending that wraps around the bulb. This is why it's a touch receptor. There's the wall of the follicle, which is composed of peripheral connective tissue. There's a sheath. It's called a fibrous sheath, as well as a glassy membrane, which is this thickened basal lamina. And then finally, the root sheath, which is derived from the epidermis. The hair matrix is the actively dividing area of the bulb that produces the hair cell. And then, as I mentioned earlier, the erectile pili is a small band of smooth muscle attached to the follicle that, when activated, will raise the follicle up and the hair sticks straight up. These are goosebumps. Okay, here's a picture of hair follicle. So we've got melanocytes surrounding the papillae. We've got a matrix, the medulla, cortex, cuticle. These are parts of the hair root. A couple different types of hair. There's vellus hair, which is pale, fine body hair of children and adult females. And terminal hair, which is the coarse, long hair found in the scalp, eyebrows. Also the face and neck of males. So let's get to the nails. Nails are scale-like modifications of the epidermis that contain hard keratin. They're protective. There is a free edge, a nail plate, and a root. It's also a nail bed. The nail matrix is a thickened portion of the bed responsible for nail growth. I'll show you a nice picture. There are nail folds, which are the skin folds that overlap the nail border. The eponychium, which is the nail fold that projects onto the surface of the nail body, also called the cuticle. And there's the hyponychium, which is the area under the free edge that accumulates dirt. Okay, so here's our free edge, our nail plate, our eponychium, which is the cuticle, and then the hyponychium, the one that will gather dirt. Under the nail, you've got the nail bed with the nail matrix, and there's the nail root where the nail is coming out. Okay, sweat glands. These are also called sudoriferous glands. All skin surfaces except for nipples and parts of external genitalia contain sweat glands. There's about 3 million per person. And there are two different types of sweat glands. There's the eccrine sweat glands. These are the everywhere glands, E for everywhere for eccrine. They're merocrine, so they dump their contents by exocytosis onto the adjacent areas. And you also have apocrine glands, which are other sweat glands. So your eccrine glands, these are merocrine. These are your most numerous types. They're abundant on the palms, the soles, the foreheads. They're regulated by sympathetic nervous system. They secrete sweat, which is 99% water, but you also have salts, vitamins, as well as metabolic waste. You have some metabolic waste that comes out of your sweat. So here's your eccrine gland. It is attached directly to the sweat pore, merocrine type excretion, and I'm showing a sebaceous gland, which is an oil gland, which is attached to the hair follicle. This is going to be a different type of secretion. It's going to dump into the hair follicle. So the apocrine sweat glands are confined to the axillary and anogenital regions. So apocrine for anogenital. And it's thought that these will transmit different chemicals for sexual identification. And so they secrete viscous, milky or yellowish sweat that contains fatty substances, proteins. There's bacteria that breaks down sweat, leading to body odor. So the apocrine glands are the ones that will produce your body odor. Apocrine glands come in two different types. The ceruminous glands, which are lining the external ear canal. These are going to secrete cerumen. Cerumen is earwax. There's also a modified apocrine gland, the mammary glands, which secrete milk. Okay, sebaceous glands. These are the most widely distributed, except for thick skin of the palms and the soles. So they don't have the sebaceous glands. They're mostly with the regular thin skin. These sebaceous glands are relatively inactive until puberty. They're stimulated by hormones, especially androgens, that lead to all sorts of acne. They secrete sebum. So this is oily holocrine secretion. So holocrine, this is when the cells are going to actually burst to release their contents, their secretant. So they're not like the merocrine signaling, it's this holocrine. It's also bactericidal, so it has bacteria killing properties, and the sebum softens hair and skin. Okay, another view at the sebaceous and eccrine glands. This is a nice little figure that looks at your everywhere eccrine glands, your anogenital apocrine glands, as well as your sebaceous glands. So the eccrine glands, the method of secretion is merocrine. It's exocytosis in a nice controlled fashion, as well as the apocrine glands are also merocrine when they exocytose their sweat. The sebaceous glands, however, are holocrine, which means that these pop. They develop pressure, and the method of secretion is popping of the follicle. The eccrine glands are your everywhere glands, except for the palms, soles, and forehead. The apocrine are anogenital regions, and the sebaceous glands are also located everywhere except for the palms and the soles. So functions of the skin. First and foremost, it's a barrier. It's protection. It regulates body temperature, especially with the subcutaneous layer. It's responsible for cutaneous sensation. There are metabolic functions like production of vitamin D. There's a little blood reservoir. When you vasoconstrict, you lose that blood in the skin, and you don't get capillary refresh as quickly as you would normally get. And there's also some waste that is excreted, some urea. The skin is a chemical barrier. It's a physical barrier and also a biological barrier. So the skin secretes sweat, which is antimicrobial, sebum, which kills bacteria, and some other antimicrobial defense. So the physical barrier is the epidermis, which provides flat, dead keratinocytes. Now the skin is lipid soluble, so there are certain lipids that go through the skin, and it's because the skin has a strong lipid component. Water is going to be repelled. So some lipid substances, you have poison ivy, you've got organic solvents, also heavy metals, some drugs like nitroglycerin, other agents. If you've got a patch with some medicine and you put it on your skin, that patch is probably lipid-soluble substances, which will then travel transdermally into the bloodstream. So the biological barriers, epidermis contains phagocytic cells that engulf invaders. The dermis contains macrophages, which are part of the immune system and present all sorts of antigens. And then there's a lot of DNA, which serves to absorb some of this UV radiation that comes in. Cutaneous sensors, there's the external receptors responsible for the outside body, such as temperature and touch, and then free nerve endings, which are detecting painful stimuli. Okay, so here's our picture again of the skin. We keep adding a little bit, but here is a lamellar corpuscle, and let's see, free nerve endings. Sorry, free nerve endings here, as well as the plexus on the root. These are all provide sensation. And then we've got our eccrine, everyday miracrine sweat glands, our erectile pillae, which when stimulated will make the hairs erect. Sebaceous glands attached to the hair follicle. You've got your 5 layers of your epidermis, or 4 if it is thin skin. 2 layers of your dermis, your papillary, your reticular layer, and then below your dermis is your subcutaneous level layer, which contains a lot of fat. So there are metabolic functions of the skin, like the synthesis of vitamin D. If you don't get into the sunlight, you can just take a pill for this. There's also activation of some hormones, like cortisol to hydrocortisone. There's also production of the enzyme collagenase, which breaks down collagen, helps turn over collagen to prevent wrinkles. So, as I indicated, skin can secrete urea, little bit amounts of uric acid and ammonia. And then sweating causes a loss of salt and water. There are a number of problems which can occur. These basal stem cells can become cancerous, and so there's basal cell carcinoma, squamous cell carcinoma, as well as melanoma. Melanoma would be of the melanocyte. So basal cell carcinoma, this is the least malignant of the three, most common. So these are the cells of the stratum basale that proliferate and slowly invade the dermis and the hypodermis. They form a little mass, and they're just usually surgically excised. Squamous cell carcinoma is the second most common type of cancer of the skin cells. These, however, can metastasize, so they can travel past their barrier into other compartments of the body. So they are more dangerous. They involve keratinocytes of the stratum spinosum. And then melanoma is the most dangerous type. It's highly metastatic, so these cancer cells tend to travel to different vascular beds, different tissue beds. They're resistant to chemotherapy. They're usually excised, followed by some immunotherapy. But there are some rules that you can look at, keys to surviving this type of cancer. There's the ABCD rule. So A is the symmetry. The lesion is usually asymmetric with two sides that do not match. There's the border, which will be irregular. Color, several colors can be contained in melanoma. And the diameter will be larger than 6 millimeters, about the size of a pencil eraser. So here's an example of a skin cancer in the lobe of the ear. This is a melanoma. You see it has the dark pigment. It's kind of green, bruised. So this is a dangerous type of skin cancer. Okay, let's look at burns, because there's a rule of nines, which is always important, but the body is broken into 11 sections, with each section representing 9% of the body surface, except for the genitals, which account for about 1%. And so it's estimated, it's used to estimate the amount of fluid loss at a burn. So a first-degree burn is the epidermal damage only, localized redness, edema, swelling, and pain. This would be like a sunburn. Second-degree burn is the epidermal and upper dermal damage, where you get blisters. This is a partial thickness burn because only the epidermis and upper dermis are involved. Third degree burns is the entire thickness, so it's full thickness burn. The skin color turns gray to white, cherry red, or blackened. You don't get a lot of edema or fluid like blisters, and it's also third degree burns are not painful because the nerve endings have been destroyed. And third degree burns usually result in some kind of skin grafting to take skin from a different region and put it onto the affected region. So here we've got a first degree burn, we have a redness. Second degree burn, we've got a blister. Third degree burn, we've got some charring. Burns are critical if greater than 25% of the body has second degree burns, or greater than 10% of the body has third degree burns, or whether it's on the hands, face, or feet with third degree burns. So the treatment includes debridement, which is removal of the burned skin. It's very painful. Antibiotics, covering, and then skin grafts. Okay, so here we go. So we've got sections of nines, legs are each 9. This is the front of the legs is 9, the back of the legs is 9, the perineum is 1. The trunk here is 18. The arms collectively are 9. I'm going to go back there to the... So you can calculate if somebody has burnt their right arm back and front, that would be 9%. If they've got both legs, that would be 36%. And so you can add that up and say 45% of this person is burned with their 2 legs and their arm. So there are a couple different special hairs that I'd like to briefly talk about. There's the lanugo coat, which are the delicate hairs of the baby in the 5th and 6th month. So in utero, they have this soft coat, this white coat. There's also the vernix caseosa, which are sebaceous gland secretions that protect the skin of the fetus while in utero. Okay, aging skin. So the epidermal replacements of the stem cells slows with aging. Skin becomes thin, dry, itchy. The subcutaneous fat elasticity decreases, and this is what leads to cold intolerance as well as wrinkles. There's an increased cancer as we age, hair thinning. The ways to age gracefully are to UV protect, good nutrition, lots of fluids, and good hygiene. Okay, that does it for the integument. I'll see you Saturday.